Hi everybody. Welcome to this morning session about Gradle plugins. The idea of this session is really an onboarding on how to create Gradle plugins, and we'll go deeper in a few minutes. First, a small presentation. I'm Eyal LEZMY, working at Jenny Mobile on a project that is called Genymotion. That's an Android emulator. If you want to find me on internet, there is all my social networks on the link right on this slide. Before continuing, I want to tell you that I work on this presentation with Cédric Champeau. We presented already at Devoxx France this year, so big thanks to him for his contribution. But I'm alone to present it today. I hope you will still like it. I want to ask you a few questions before starting the content of this presentation. The first is, because I want to know you a little bit, who are Android developers in the room? Raise your hand. Oh, a lot. Okay. Well, I could have something interesting to tell you at the end of this conference. Okay, for sure, who use Gradle has a build system? Yes. Who already tried to build, first other question, who customize his build system right now by creating a few tasks, scripting, yep, okay, and who already built a real Gradle plugin? Not too much, great. So for you guys that already tried to build a Gradle plugin, this is really an onboarding. It's not done for very advanced and skilled content, but I will propose something for you at the end of the slides. Maybe there will be a few things you can catch from this talk, and for all the others, we'll go through the Gradle API to go deeper, but really starting from scratch. The slides of this presentation are available following this link, so you can have it right now if you want to follow easy. But the screen is so big here. For sure you will be able to read everything. Okay, let's try to start. So let's start. Here are some definitions. We'll begin with what is Gradle. What is this technology? So you use it as a build system, but technologically, what is for real? Here is the definition by Luc Dailey. He's a core Gradle developer, and he defines Gradle like first a dependency management engine. But it's a small part of the project. It's also a dependency management a dependency-based execution system. The idea is to bring different dependencies and make them build a project together. But it's also, and that's a big and a very interesting part of this technology, it's a plugin system. And of course, because that's a plugin system and the core is not so big concerning the code that is executed when you build your project, that's also a big set of plugin. And today, together, we will try to contribute to the set of plugins that are already existing with Gradle. There are different kind of plugins. So if you look at the code and how your project are interpreted by Gradle, the build.gradle file that you manipulate every day are considered a plugin. So this is the first type of plugin you already use every day. There is also scripts plugin that are using the Gradle API that I will show you today, but we will more focus on the binary plugins that are plugins using the API that you bundle into a jar file or any format you want to be able to export it and use it on different projects. Another definition is a Gradle task. Gradle task is first a piece of work. Everything can be a piece of work on a build. For example, compiling a class, copying a file, building an APK for Android applications. these tasks can be manipulated. You can inject code before and after using these kind of API, like do first, do last. It's also typed. It means that you can inherit. The copy task is a good example because instead of creating from scratch a task that is supposed to copy a file, you can just inherit from the copy task, and we'll see how we can do it together to have your own and just configure it to make it your own into your plugin. And then very important point, tasks in Gradle are dependent each other. So when you are launching a task like test, like assemble debug for Android developers, it will launch a chain of tasks that will be executed, and it forms a graph task that we will tell about later, and there are some APIs to manipulate that, like depends on and finalized by. But we will go a little bit deeper in a few minutes. So let's start it. Here is, we will try to build this plugin together, and here is the problem that we have to solve. So there is a Yoda droid that is asking, because he's really that's like a manager for every developer, right? Yoda. So he asks for us today to do a simple thing. When we are launching a test, there is a report that is generated by a Gradle or any framework you use. And what Yoda asked us to do is to take this folder and just version it using a timestamp. Really, that's very simple. And let's see, so this is our project structure. And he just wants us to copy this folder, each test, when it's finished, add a timestamp so it's versioned, and that's all. So that's a very simple use case. And basically, you can already do that from your build.gradle. You can add a task here. We call it archive tests. It's a type copy I told you about already. And what we do is that we just configure sorry, we just configure this task to copy this with the from property, this report folder to a new one, getting the timestamp added into the path. Okay, so that's very simple. And what we do then is that we take this new task and we made that the test task using task.test.finalized by pointing to archive test. So basically, test, when the test task will finish, archive test will be launched. Okay? So that's very simple. And we will see together how to make it more complicated, but for good reasons. Okay, so how to build a plugin. First, why to use a plugin? Why to build a plugin? Because you've seen this problem can be solved in 5 lines. And we make it bigger with more code. But by doing this, we will be able to use it very simply on different projects. We will be able to share it with the whole team, maybe with the whole world. And also, because a project is supposed to answer to one question, if you add this kind of dependency logic into your build system, you don't stay focused on what you want to do with this project. And that's not so good. And because when you know the API that we'll discover together, you will see that it will be very easy for you just to bootstrap a new project and build new plugins. Okay, what is concretely a binary plugin? So first, that's a Gradle project. And on this conference, we will use a Groovy project. So every code that I will show you will be in Groovy. What it contains, of course, because that's a Gradle project, it contains a build.gradle, that's its own, to be able to build himself. A plugin class, that's the entry point of the plugin. A descriptor that is used to package, you will see it will point to the plugin class. one of several tasks because you want your plugin to do something. So of course, you will create tasks that will be executed, and an extension. The extension is a very important concept because it allows you to create the DSL. That's the way for your user, the user of your plugin, to communicate and to configure with your plugin. And we will go a little bit deeper together. So for all of you that are already using Gradle as a build system, you maybe use the Java, the Groovy, the Maven, the Android plugin already. So that's fine. So this is the architecture of the project. That is really simple. You can see that we have this plugin class, the task class also, the extension, the descriptor. The descriptor is by convention into this folder. So that's a weird architecture, but just follow it. That's very simple. And the build.gradle. Okay. So now we will take all these classes and see how we can implement them and discover the Gradle API through this project. This is archive test plugin. It implements plugin templating a project, because basically you could implement different kind of plugins, but what we want to do today is to a plugin for a project. These class have to implement an apply method that is taking into has a parameter the project that is currently building. And there are mainly three things to do on the apply method. You will create your extension that I told you already about. You will create the task that will be executed, and you will link the task to the build chain, to the graph task. So here it is. We create, using this API, project.extensions, we create an extension that is called archive tests. With the, this is the type of the class that will be used as an extension, and we can also provide parameters like this. It will be added directly to the constructor of the extension class. So we create our first extension together. Then we create the task using project task. The task name is archive test, and the type is archive test task. Okay, we get it. That's really simple. And at the end, we get our task that is that we are reaching using the project archive test task. What we are doing basically right here is that we are taking the project object that we have. This project contains now our archive test extension, and inside this extension there is the task property that we are reaching to get the value inside it, and we will see what we will have inside this method. But basically for now, that's a test label. Means that we are going to get the task, and we take this task and we finalize it by our archive test task. Is it clear for everybody? Yeah? No? If you have questions, don't hesitate to raise your hand. We will try to answer the questions. So now let's go for our task, archive task. This task extends the copy task, as we shown on the previous example. Really, the thing we want to do is copy a folder. That's really simple. Yes, so that's an example using the copy task, but in most of the time you will maybe want to implement your own task from a default one without any logic inside. So you can use a default task. That's the API for that. And also, because the copy task does everything for us, we don't really have to do logic on our side. But we really want for this presentation, see if our tasks are well executed. So we added println to just show a message that everything is working fine and our task is executed. And how we define the function that will be launched as an execution of our task, just by using this annotation, task action. Then the method name can be Toto, Tata, everything. It will working. What you have here also in the constructor of the task is that we are setting from and into, like we've done already, using the archive test extension. So we get the project because we are on a task, so everything is done upstairs using the mother classes. So on the project, we reach the archive test extension and we get the from property and the into property for the from and into properties of our task. Okay? So we continue. So basically, we've done our task, we've done our plugins, our entry point, and let's try to see what DSL we want to implement, how we want our user to customize our plugin. Because the idea of a plugin is to be a little bit generic and being able to be configured by the user. So what I would like to do by building this plugin is to have an archive test block that can be declared on the user on his build.gradle with 3 properties that can be set: from, into, and task. Okay, so let's see now sorry, how to declare, how to create this extension. So as you see, basically, an extension is a POJO, and because we are using Groovy, we can call it a Pogo here. And what there is into this Pogo is very, very simple. 3 properties: from, into, and task, with a constructor that takes projects. And we set default values into the constructor for from, into, and task. So by default, our plugin will use the test task to be injected into. Okay? And that's really what you see here is really the point of developing a Gradle plugin. You should implement default values so the user can just avoid configuring your plugin. So you propose a default behavior, and using the DSL, your user will be able to change the way your logic is supposed to be linked, or by adding these kind of parameters. This is also the one of the last element that I've shown you already. The descriptor is this a very simple file, and it contains the class that have to be pointed by our plugin. So basically, the entry point for the user and for Gradle for our plugin is the archive test plugin class. And what you note here is that we call this file archive test.property. And this means that when the user will apply our plugin, it will name it archive test. So the name of this file will give you the name of the plugin inside the build.gradle of your user. Okay, so let's see now our build.gradle, because we are a Gradle project, so we need to configure a little bit a few things. So that's a Groovy project, so we apply the Groovy plugin. We are also adding as a dependency the Gradle API, because that's the API we are using. And what you have just behind it is a method that you can call to add the Groovy dependency. But depending on the Gradle version that you will use, the Groovy version that is supposed to work with Gradle can change. And local Groovy will just get the current Gradle version that you are using to compile and inject the good dependency for Groovy depending on the Gradle version. What we do then is that we apply another plugin, Maven Publish, to be able to publish our plugin as a jar file, as a Maven dependency, like this. We open this element, we call it Maven Java, and we ask it to use Java components as content of the the artifact. Sorry. Okay, so now our project is ready, and there is almost everything to be able to run it very simply. So we'll take the place of the user and see how he can use it. So how a user can do to use a plugin. So he had to add a repository, the repository where your binary is located. Then you add the dependency, like you always do. Then you apply the plugin, and then you configure the plugin if needed. Okay, so that's very simple. Now our plugin is supposed to run on build script because we are not deploying our project when we are using our plugin. We are running tests, so we had to add this plugin in a build script dependency. We deployed it on Maven local, as you've seen with the Maven publish project, and we add this dependency. So that is the way the dependency is built. When you are, I come back to the build.gradle. So what you see here, group and version are defined here, and the artifact will be built following this information. So the class path is made by the group, then the artifact ID, then the version that is defined into the project. Then the user can apply finally our archive test. And how you see, it launch apply plugin quoting archive test. What it will do at this moment, it will call our apply method into our plugin. And everything that we implemented inside will be executed. Then it configures the plugin the way he wants, from, into, and task, using our extension. Okay, so we have our plugin, it's ready, it's on Maven local, so the user can reach it, put it in his project, and set everything he wants, and configure it if he wants. So now let's run it. So here's an example of what the user can put into his build.gradle. So now he will use from, and it changed the from directory, and it changed also the into property to just put it on another path that we already configured by default. And then he launched his tests, and everything is fine because you've seen there is this report copied into that is added into our output, so we know that our plugin worked well. Okay, and we are very happy at this moment because that's our first Gradle plugin, right? Okay, so here is another example of what a user can do using our plugin. He used archive tests, the same than before, setting from and into, so we know that, and then he's adding another thing, the task. He's configuring the task property, setting it to hello. Then, right behind this declaration, he creates a new task called hello, doing whatever he wants. Okay? So let's try to run this. Yeah, so basically what he wants to do now is he wants that the directory he defined before is copied directly right after the hello task execution, right? And of course he created the hello task. I already told that. So then he launched the hello task, and the build is successful. Everything is working on the build side, but our plugin is not executed, and that's a problem. That's probably a bug, and that's probably made us very sad. And we have to find a solution to fix this bug, and we'll try to do it together. So let's analyze what is happening when the user use our plugin and define things into his build.gradle. So first, he apply our plugin. So what this method is doing, basically, it creates the extension. Do you remember? Then it sets into the constructor of the extension archive test.task to test as a default value, right? Then it creates our copy task that is called archive test task, something like this. And then it finalizes the content of the archive task. Sorry, it get the archive task property, get the task that corresponds to this content, and then link it to the new task that we created that he's supposed to copy. Then he modified the content of the extension from test it passed to hello, and he creates his task. And to understand a little bit more what it is happening, we'll try to build together a graph task. So first, we apply our Java Groovy Any plugin, and this plugin will create the task, the test task. Then our plugin is applied, so we create the archive task, archive test task. Oh, sorry, maybe that was very wrong name that I choose for this presentation. And then the apply is finished. We'll connect our archive test task to the test task, and then the user creates his hello task. And what you see here is really not the result we want, because at the end we want the archive test being linked to the hello task and not to the test task. So when the entry point is hello, it's executed, there is no way to go and to launch the archive test. Okay, so we identify the problem into the graph task building procedure, and we will try to see inside our code what is the real problem. So we are back on our plugin class. And what we see here is that the linking happened too early on the build process. So we get the origin of the problem. We get where the code is lacking of consistency. But before fixing it together, we take a moment just to consider what is a Gradle build lifecycle. We can identify 3 steps into the Gradle build lifecycle. The first is the initialization. During the initialization, the Gradle will deal with all your project's dependency and see what have to be built and in what order before starting to build. Okay, so that's the first step. For our project, it's really not a problem because we only have one project. But when you have multi-project dependency, that's where it starts. Then there is the configuration. And in the configuration, there is a very interesting step that is called the evaluation. And during this evaluation, all the build.gradle of the project will be evaluated and executed. So that's when the build.gradle and the DSL declaration are executed. And at the end of the configuration, the build task graph is supposed to be built. Then when the graph task is built, the execution starts. Okay? So we know that, and the problem is that, right before fixing it. So here, during all this process, there are a lot of nice information to get, and part of them are events that you can trigger, and then you can launch, execute your own code following these events. For example, during the evaluation, there is the before and after evaluate event that you can listen. And for the task graph, you have other events you can trigger also. One will be very interesting for us. It's the after evaluate, because we want the user execute his build.gradle, so configure our plugin before using this project archive test task property to inject it, our task into the task graph. So what we are doing is very simple. We add project.afterEvaluate at a good place on the apply method, and everything is supposed to work well. So the result after this change is that we have these test tasks that have no children, basically not our children, and the hello task have the good is finalized by our own task archive test. And we are very happy of it. Okay, so we finished to build our plugin. That was simple, right? But that was a good way to discover a part of the Gradle plugin API. But because it's a project that is supposed to be maintained, we will test it and add a few tests, and we will see together how to do it. I won't go into the how it's good to test. It's not the purpose of this presentation, but I really advise you to test it. First, because it's very simple. Then you can write your plugin in Groovy, and Groovy is a very friendly language when you want to mock, stub, and everything. And it's also fully compatible with all the libraries and frameworks that you are already using to test your Java project or any language that you already use. And there is also one very important point about testing your Gradle plugin. For now, I didn't succeed to plug a debugger when my user was using my Maven dependency, my Maven project. It's feasible, but it's really hard. And when you develop your plugin and have a test that you can execute, that's extremely easy to access the debugger and to find the problems like we've seen together. So that's really a very good thing to implement tests for a Gradle plugin, because it will be very easier for you to debug it when you develop. So basically, that's really a Groovy project. So there are no specificities on the Groovy part, but there are two things that I want to tell you about a Gradle project and how to stub it. So that's a tip. We will be able to stub the project together, and also I want to tell about the evaluation. So we add this class containing a test. We add the JUnit dependency. So how to add the JUnit dependency? You add a JUnit, a gcenter to your repositories on your build.gradle. Then we add the JUnit dependency. What we want to do as a first test is to check if our extension is good. You will see that's a very simple test. So what we are doing first into our test method is that we are stubbing a Gradle project using this API, project builder.build. Then we receive a project, a stub project on the other side. Then we apply the Java plugin, for example. It can be anything else. And we apply also our plugin. And when it's finished, we just check that project archive test contains a good type. It means our extension. So that's a very simple test. And now you know how to do it. Okay. So next step, we want to test our class, our task. So we stub our project on the same way than before. And then what we are doing is that we get the task of the project, we get the archive test task, and check if it's the good type also. And when we run it, we just figure out that our archive test is not accessible on the task graph, and it's not accessible for our project. Before going deeper into this problem, I want to tell you something that I squeezed because I didn't have the time to add it. But most of the time, when you try to, when you start to do advanced plugin development, you will have to create to create a lot of tasks, and not just one like we've done already. And how you can do it is by getting the input from your user. So when you use your DSL, you get the information. So, sorry, you will have to create all your tasks into the after evaluate trigger. Most of the time, that's what's happening. And the problem is that the after evaluate is called only after the evaluation of the project. And for now, we didn't evaluate. We just create the stub, apply plugins, and then nothing happened more. So, our Yodaroid asks to evaluate the project. So let's evaluate the project. Yeah, we use that, evaluate. But when you are looking for the documentation, you won't never see this method. But let's use it. We don't know, just do it like this. And it works. That's wonderful, right? So this is really a method that is not documented. And by looking after trying to solve this problem, I went on the web and I've seen this post that was telling a guy complaining about the evaluate method that was not documented. And this is an answer that I found on the Gradle forum. And the guy said, "You don't see these API docs. You don't see this in the API doc for the project because that's an internal method." And he finished with, "There will be a supported mechanism for doing this kind of thing in the near future." The guy that answered this is Luke Daly, that I quoted at the beginning of this presentation, part of Gradle project, and that was in June. Oh, that was in June 2011. So the near future is a little bit far for now, and basically, sometimes you have to deal with it with projects. So we finished our plugin. That was very simple. As I told you, that's an onboarding. Then we know how to test it on a good way, even by using a non-documented method that we find together, right, on the web. Let's try to give you a few hints to try IMPROVEIT. First, there is Maven done a very good thing. It's bringing the convention over configuration concept for the build system, and Gradle really fits to this mind, and that's really a leitmotif of this technology, and that's a very, very great thing. I can tell you, for example, one thing that is very interesting, using plugins. On Java, when you are applying the Java plugin, you are applying actually two plugins. One is the base Java, and one is the DSL Java. It means that one plugin will be able to compile and knows how to compile Java classes, and the other is the real convention. It means that the file have to be on this position. You can configure your build using this extension, etc. So they really divide the compilation and the logical part from the DSL and from the convention. And for the Android project, that was a very interesting point, because the Google team that built the Android build system, how we build APKs, they used the exact concept. They take the Java base because they need to compile classes, and they just use their own convention plugin, plug into only the Java base plugin to make their own tool. And that is a good sign of the modularity of how you have as a Gradle plugin developer to think about the structure of your plugin. As soon as you can, if you can split the convention part from the logic part to let people use your plugin the way they want and to interact with it easily. Another point is that what we've done on this plugin, reaching a named task to inject our task after it, is not the better way to do. That was just the use case that I wanted to show you, because there are a lot of ways to use, for example, the type of the task. For example, any test task is supposed to inherit from test task declared from Java or Groovy plugin or any other. So there are many other ways to have to implement genericity and use convention declared by all the Gradle plugins to make it better and to make it easier for your user. Another point is that in Gradle, that's very simple to implement incremental builds. The idea of the incremental builds is that if the input is the same and the output is the same also, you are not supposed to execute a task, and you can just skip it and go after it. So that's very easy to do, and that's something that you can use very easily by annotating the properties into your project, into your extension. And another thing that I wanted to tell you about is that you're not always obliged to run your task, and there are also other API that allows you to skip task execution. So for example, if our parent task for our ICAV task was not supposed to be run, you can use the only if API to skip your task execution. So that's the last point of how to improve your Gradle plugin implementation. But there are many others. For this presentation, I want to give you a few references. One big, and that's really the source of the content you've seen during this presentation. That's the Gradle plugin official documentation. For the onboarding part, the documentation is really great. You have to read it. That's long, but that's really complete, that's really understandable, and that's really interesting. Except this evaluation method problem, but that's you should read it. Another thing is that this was really an onboarding, and I built another conference that I gave already at DroidCon London and Paris about how to take your plugin from develop from scratch, as I'm showing you, to the next level by building and improving your DSL, by also interact your plugin, to make interact your plugin with the Android official plugin, how to test it a little bit more accurately. You have the link on this page. So here is again the slide, the link to the slide if you want to get it. I hope you enjoy this talk, and if you have questions, I will be happy to answer it. Thank you. Any question? That was so clear. So I think we are fine. You will be able to find me on the conference for the whole day. I will be here.